Hello and welcome to Knauf Insulation's customized flat roof application. In this application, you can draw the shape of your flat roof. Based on the drawing, the application calculates the position and quantity of the inclined insulation slabs. You can find this application at customized-flatroof.com. You can sign up by clicking right here. If you're signed up, you can then log in with your username and password. Once you're signed in, you will see the user interface. On the top left corner, you have a home button which returns you to the page you see now, a project management button and a projects button where you can manage your designed roofs. On the right hand top corner, you have the log off, user settings and change password buttons. To create a new project, you have to click the Add button. A window will appear. Here you will input some basic information about the project. First, we insert the project name. In this example, I will just write New Hospital. Secondly, we insert the address where the flat roof will be built. In my case, this will be an imaginary address. Thirdly, you insert your contact information. This could either be your name, name of your company, email or phone number. Then we have to select the country in which this project is situated. Here you can find a list of countries available for now. With time, this list will get bigger as we roll out the application. If you can't find the correct country on the list, just click Slovenia and we will help you in any case. You can also find the emails of the sales and technical support team here. For our demonstration project, we will set the location to Slovenia. Afterwards, we can add a comment like basic information about the project, for example, when is it going to be built and are there any special demands about the project, etc. Now that we have all of the basic information, we have to add a design to this project. We click the Add Design button. Here we now have to enter technical information about the flat roof. The project can have more designs if need be and as many as you want. For example, if we have a complex building with two different flat roofs, we can click the Add Design button one more time and an extra design will appear. Now we insert the design name. For us, it's going to be roof number 1. Next, we add the roof inclination slope in percentages. This is specified by the architects or roofers and it's usually around 2%. Next, we have to add the drain height. This can be seen from the architect's drawings, usually a drawing that includes a cross-section of the roof. This is the measurement from the most bottom part of the insulation that usually lays on the load-bearing structure and to the top of the drain. In our case, let's say that the architect specified that the roof has 150 mm of thermal insulation. On top of that, they added 20 mm of inclined insulation slabs that represents our starting slope of the roof. In this case, the roof drain height would be 170 mm, 150 mm for the thermal insulation and 20 mm for the inclined insulation. Inclined insulation starting thickness is predefined at 20 mm, but you can add more if needed. If the architect would change his mind during the project, this can be easily modified here and the application will recalculate everything. However, our recommendation is to stick to 20 mm when possible. Now that we have defined all of the necessary information, we click Save. A new window will appear. Here you will see all of the information that you defined. You also have a design multiplication prompt, which only comes in handy when you have more flat roofs of the same design. Let's say that we're building 5 houses that have exactly the same flat roof designs. Then we would write 5 here. In our case, our building only has one flat roof of this type. We leave the anti-inclination tick mark empty. Now we can start drawing. On the left-hand side, you have the design data and design screen tab. We click the design screen to start drawing. This is our drawing area. On the left-hand side, we have the modeling tools with which we will draw the shape of the roof. We have the Select, point, line, free arc, circle and rectangle tool. Mostly you will use the line tool for drawing. We will get back to these functions later. Then we have the canvas tools and settings. These functions mostly help us navigate around the drawing or make our life easier. We have the undo redo function. You can move or rotate objects on the drawing board. If you're not happy with the drawing you see, use the function clear all that will erase everything on the drawing board. You can zoom in or zoom out, but you can also do that with scrolling up or down with the middle mouse button. You also have some snap functions. The snap to grid function will snap your mouse cursor to the grid on the drawing board. The snap to corner will help you snap your mouse cursor to the start, middle or end of an object. Orthogonal snap means that you will only be able to draw the lines under perpendicular 90-degree angles. If you don't like seeing the grid, you can untick it here. Lastly, we have the descriptive tools. Once the roof has been drawn, we will have to add the location of our drains. We can add a point or line drain. The breakthrough tool helps us make breakthroughs in the roof. For example, if we have an elevator or chimney shaft that is coming through the roof, we can mark it with this tool. Finally, we have the reference point tool, which is here only as a help tool when we want to draw a line or a point, etc., in a specific location on the roof. The last function that I would like to mention is the pan function. If you press and hold spacebar while you are on the drawing area, you will be able to move around the drawing area. This is a very helpful function for navigating. First, we will draw a simple roof shape so you can get a feeling for the application. Afterwards, we will draw a more complex roof shape where you will upgrade your skills. Let's select the line tool and snap it somewhere on the grid with a left click. We have to add the length and the angle of the line. In our case, this is going to be 12 meters and 0 degrees. Now we press enter. What is good with this application is that you can immediately continue drawing lines. If you don't wish to do this, you just press escape. But let's continue drawing. The next line will be 10 meters long under a 270-degree angle. We can confirm this also just with the click of the left mouse button. We make a third and a fourth line to get a rectangle shape. This area represents all of the area where the inclined insulation will come on the roof. This shape does not include the thickness of the external walls, which would be on the outside of this rectangle. One important thing to keep in mind is that our roof has to be fully connected and closed in order for the application to make a calculation. Now that we have drawn the shape of our flat roof, we have to insert a drain. Click the drain tool. In my case, I'm going to untick the snap to grid function and tick the snap to corner function. This will allow us to snap the starting location in one of the rectangle corners. We click on the left lower corner. You will see that two guidance lines appear for placing the point drain. The A dimension is the distance of the point drain from the starting point on the x-axis. In our case, this will be 3 meters. We press enter. The B length is the distance of the point drain from the starting point on the y-axis. In our case, this is going to be 5 meters. Press enter and the point drain will now appear. It is a small red point as seen here. Now we will draw the second point drain. The A dimension for this one is going to be 9 meters and the B length is going to be 5 meters. We press enter and now we have our final roof drawing. I recommend that you click save on a regular basis so you don't lose your work. Now that we are satisfied with our drawing, we click calculate. The application will now calculate the design of the flat roof, meaning that it will draw the most optimized way of draining the water towards the drains. In our case, we have 8 slopes going towards the 2-point drains. These slopes will be created with inclined insulation slabs. Right now, we are working in an architect role in the application. This means we have limited vision of everything that the application actually calculated. You will have to click the Send to Review button, and this will open a tab where you can write a comment for Knauf Insulation's technical support and sales team. You can also leave it empty and click Send. Now that you clicked Send, the technical support and sales team will be notified about your design, and they will be able to send you more information regarding your project, like the bill of materials, full roof drawings with slab positions, etc. You can also export the roof geometry on your own. We click the Export Roof Geometry button. A Word document is downloaded that includes information about your project and also a JPEG picture of the drawing. Here you will also see the roof area information. In our case, that's 120 square meters. It also includes information from which boards this flat roof is going to be made. We have the baseboard insulation slabs, which represent our thermal insulation in the thickness of 150 millimeters, and then we have our inclined insulation slabs that are the insulation slabs which create the slopes of the roof. At the beginning of the project, we defined the starting thickness of the inclined insulation slabs to 20 millimeters. The flat insulation slabs are used as a padding material to the inclined insulation slabs where the application sees the technical need for it. There you go, this is our first design. Here is a view of what Knauf Insulation's technical support and sales team sees when they receive your drawing. The drawing shows all of the inclined insulation slabs used in the calculation. Each type of board is represented with a numbering, as you can see the numbers on the drawing. Our technical support will send you all of this detailed drawing, and they will also send you a bill of materials. In the bill of materials, you can see all of the quantities needed to make this roof in real life. For example, you will need 16 pieces of smart roof top, CTF1, in length and width of 1 meter, with a low thickness of 50 mm and a high thickness of 70 mm. This means that the height difference from one side of the board to the other is going to be 20 mm. You can also see the volume and density of the boards. Keep in mind that the cost estimates that you see below are imaginary and are not relevant. The technical support will send you all of the drawing and bill of materials either in Word or Excel, whatever would suit you best. Let's generate a document in Word. The document will look something like this, with all of the project information, total bill of materials, volumes, and pricing. You can see that all of the baseboard, inclined and flat roof slabs have been separately listed. Technical support can also generate you an Excel document with the same information if it's easier for your business process. On the left lower corner, don't forget that you can open 2 extra tabs with relevant information. Let's go to our second roof design. To get back to your project, we have to click the Project Management button. Below, you will now see your listed project. Click on your project. Because the second roof is part of the same project as the first roof, we just click the Add Design button. We leave the same project name. The roof inclination slope and inclined insulation starting thickness values will also remain the same. We have to insert a new design name, however. In our example, we can just write higher building part as the name of the second design. We increase the drain height to 250 mm. You can add a comment if you want, but for this example, we will leave it empty. Now we click Save. A familiar window appears, the same as with the first design. We click the Design Screen tab, which can be found on the left-hand side of the screen. Now we can start drawing our second roof. This roof will be more complex and eccentric. I'm going to uncheck the Snap to Grid tick mark and check the Snap to Corner tick mark. Let's start with a line. Click on the Line tool. Left-click on the drawing area and insert the length of 15 meters. Press Enter and insert an angle of 25 degrees. Press Enter again. We continue drawing in the horizontal direction. We insert a length of 13 meters under a 0-degree angle. Now we click the orthogonal snap. We will only be able to make lines under 90-degree angle increments. Write down the length of 15 meters. The angle is locked, so just press Enter. As we don't want to continue drawing with the line tool, press Escape. As we made this in a continuous motion, if we press Undo, it will erase everything that was drawn in such a way. If we make a new line and press the Undo function, we will undo just that line. As we don't need that new line, we will just keep it erased. The next thing what we will do is insert a reference point, which will help us create a 3-point arc later on. Click on the reference point button. Make sure that the snap to corner tick mark is checked. Let's also uncheck the orthogonal snap. Now, let's left click on this corner. On the A length or the x-axis, we will input 0 meters. Press enter. On the B length or y-axis, we will input 15 meters. Press enter. Now let's use the 3-point arc tool. We can use it in a clockwise or counterclockwise direction. It doesn't really matter which you choose, as you can get the same result with both of these two options. We will choose a clockwise direction. Now let's click on the previously drawn reference point, and with the second left click we choose the corner of the right line. An arc will appear. You can specify the radius value and press enter, or you can specify the radius by left clicking on the drawing. The radius of this arc will be 7.3 meters. If we want to move this arc, we must click the Move tool. Select the arc, press enter, and then we have to press and hold the left mouse button to move it around. As we really didn't want to do that, we will click Undo. We can also rotate the object. Click on the Rotate button, select the arc, press enter, click on a corner, and rotate the object around. You can manually write down the desired angle. You confirm it by pressing enter. As we didn't really want to do that, we will click Undo. Now we can continue drawing our roof. We select the line tool. We check the orthogonal tick mark and start drawing. We insert a length of 13 meters and press enter. Now we must close our roof, otherwise the application won't be able to calculate. We make another line that will bring the roof together. Make sure that the orthogonal snap in this case is turned off, as we don't want to make a straight line down. When you connect both corners with the line, the application will give you information under what angle the line was made. Press enter. The basic roof shape is now done. All of the corners are connected and the roof is closed. Now we will insert a line drain. As the line drain in this project is positioned on the 13-meter long line, we will choose that line to represent our line drain. We click on the line drain tool. We then select that to represent our line drain. It will turn into a red color. Please note that line drains in roof designs are usually 20 centimeters more or less away from the edge of the roof. When you're drawing in this application, however, just select one of the roof edge lines to be the line drain. The on-site construction workers then adjust the inclined insulation slabs manually on the construction site so everything fits together. Now, we are going to make a line drain somewhere in the middle of the roof. We will make a reference point that has an A length of 0 meters and a B length of 7.5 meters. We will make a line from that reference point. We check the orthogonal snap, we click on the reference point and specify a length of 10 meters. We press enter. And don't forget to select the line tool beforehand. We still have to mark that this line is actually a line drain. We click on the line drain tool, click on the line in the middle of the roof and press enter. The line turned red, which confirms that it's now a line drain. This roof also has an elevator shaft that is going through the roof. We have to draw it first. Click on the reference point tool and click on the corner. The A length will be 3 meters and the B length will be 3 meters as well. As the elevator is of a rectangular shape, we can now use the rectangular tool. Click on the rectangle tool and then click on the drawn reference point. Now we have to insert the length and width of the rectangle. On the A length, we insert 4 meters and press enter. For the B length, we insert 4 meters as well and press enter. The elevator shaft is drawn, but we still have to mark it as a breakthrough object. We click on the breakthrough tool and we mark each line of the elevator shaft and press enter. There you go. You have drawn your first breakthrough object. If you're not satisfied with the design of the roof, you can press Clear All. But as we are satisfied with what we've drawn, we will undo this. Don't forget that you can pan around the drawing with the space button pressed down. We're still missing one point drain in the middle of the arc, which was specified by the architect. We click on the drain tool. Click on the corner and insert an A length of 6 meters and a B length of 16 meters. Now we also have a point drain. As we have everything drawn and all of the roof connected, we can click Calculate. The application will calculate the most optimal position of the inclined insulation slabs. Now that the application finished its calculation, we can see that we have 6 different slope directions. We can export this roof geometry. If we are not happy with the roof design, we can also click on the Edit Roof Geometry to improve the drawing or drain positions. In our case, we are satisfied with the drawing, so we click the Send to Review button. You can insert a comment if you wish. We'll write that we finished designing the second roof. Here you can now see what our technical support and sales team see. Once they get this information, they will get back to you with all of this information. You will be able to get full drawing information with a complete bill of materials. They will be able to generate an Excel or Word document for you with all of the relevant information. If we scroll down, you will also see a JPEG picture of the final roof design. That's all! Thank you for listening to our tutorial and we hope that you find it helpful. Have a great day! Bye bye!